Hello everyone, welcome to the Electron Flow Academy. So today we are going to discuss about the numerical problem number 2 based on the RLC circuit. Okay, so the question is given to us is that a 100 volt 80 volt lamp is operated on a 230 volt 50 hertz supply. Okay, so calculate the value of a pure inductance to be connected in series with the lamp so that the lamp run on its correct voltage. Firstly, we need to calculate the value of the required inductance. Okay. Secondly, in the question they have asked us if the power factor of the lamp circuit is to be improved by unity, then calculate the value of the capacitor which is to be connected across the circuit. Okay. Secondly, they have asked us that required value of the capacitor need to be connected across the circuit if we need to do the value of the power factor is equal to 1 or unity. Okay, so let's start solution. Firstly, from the given rating of the bulb we can find its resistance and its rated current. Okay, so power is equal to P square divided by resistance of bulb. Okay, or we can write this R of V is equal to P square divided by power. So resistance is equal to power is given to us is 80 watt and voltage is 100 volts. So 100 square divided by 80. Okay. So from this expression I have calculated the value of resistance which is equal to 125 ohms. Okay. So I have calculated the resistance. Next thing is that the current rating of the bulb. Okay. So current ratings of the bulb. So I is equals to voltage rating divided by resistance of the bulb. Okay, so now the current is equal to 100 divided by resistance which we have calculated here 125 means the value of the current is 0.8 ampere. Okay, so the permissible current in the bulb is 0. Ampere. The permissible current in the bulb. Okay, so next thing is that here let an external inductance L, assume let an external inductance which is L having a reactance of XL E connected in series, then circuit will look like this. Okay, and this is connected across the AC voltage P is equal to 230 volt 50 hertz. Okay, and current which is flowing in this circuit is 0.8 ampere, which we have calculated here. Next, this is your resistance of the bulb, and this is the inductance, which reactance is XL. Okay, so this is we have assumed here. Okay, 1 minute. Next is that this is we have assumed here. Okay, so next is that impedance of series combination which is equal to Z is equal to V divided by current. Okay, so voltage is 230 and current we have calculated is 0.8. Okay, so here the value of the impedance is equal to 287.5 ohm. Okay, and also we know that the impedance is equal to resistance plus J times XL. Okay, so let's put the values here. So we know the value of the resistance here is 125 ohm. Okay, and 125 plus J of XL. Okay, also we can rewrite this expression like, or Z of square is equal to 125 square plus XL square. Okay, so here X of L is equal to under root of Z square, meaning 287.5 whole square minus R square, which is equal to 125 whole square. So this is how we have calculated the value of XL. Okay, so the value of the XL is 258.9 ohms. Okay, so here we know that the XL is equal to 2 pi FL, which is equal to X of L, meaning from this expression I can calculate the value of the inductance, required inductance. So L is equal to 258.9 divided by 2 pi F. Okay, so 2 pi into F. F is given to us is, this is 50 F. Okay, so after solving this, the value of the required inductance is 0.824 Henry. Okay, so here we have calculated the value of a pure inductance to be connected in series with the lamp so that the lamp runs on its correct voltage. So this is the first answer. Okay, next. So next we need to calculate is that 1 minute. Yes. The next thing is we need to calculate here. We need to calculate the value of the capacitor. Okay, in order to improve the power factor by unity. Okay, so let's assume 1 minute here. Let a capacitor of the capacitive reactance Xc, okay, of capacitive reactance XC be connected across the circuit to improve the power factor to unity. Unity means 1. Okay. So the condition of the power factor is unity is that when the load is of pure resistive. Okay, this is the condition of the unity power factor, that the load is type of the pure resistance. So let's draw the diagram. Diagram is like looks like this. This is our resistance. This is our inductance. So value of the inductance we have calculated here 285.9, and the value of the resistance we know that 125. Okay, so this is resistance which is equal to 125 ohm, and this is the inductive reactance which is equal to J258.9 ohms. Okay, so here this is our supply voltage. Okay, the value of the supply voltage is 230 volts 50 hertz. Okay, so question is asked to us is that if the power factor of the lamp circuit is to be improved by unity, calculate the value of the capacitor is to be connected across the circuit. Across the circuit meaning parallel of the RL combination. Okay, so here if I connect the capacitor like this, then I have to calculate the value of capacitance. Okay, in order to improve the power factor to or by unity. Okay, so let the total impedance of the circuit is assume that Z equivalent. Okay, so Z equivalent is equal to, we need to calculate, which is equal to by the combination of the circuit we can say that this capacitive circuit is parallel with this resistance and the inductance format. Okay, so if I solve this in the parallel, then 1 upon Z equivalent is equal to 1 upon Z of L plus 1 upon Z of C. Okay, so here Z of L is equal to the combination of both resistance and inductance. So 125 plus J of 258.9. Okay, so if I change this in the polar format, then the value will 287.5 at an angle of 64.22 degree. Okay, and we know that Z of C is equal to negative of JXC. Okay, so we can rewrite this equation, this expression like 1 upon Z of C is equal to now J multiplied by 1 upon XC. Okay, so here 1 upon Z equivalent is equal to nothing but the equivalent admittance. Okay, of the circuit. So Y equivalent is equal to 1 upon 287.5 at an angle of 64.22 plus J into 1 upon XC from here. Okay. So after solving this, Y equivalent is equal to 0.003478 at an angle of minus 64.22 plus, sorry, plus J divided by X of C. Okay. Next, here the Y equivalent is equal to 0.001512 minus J 0.00313 plus J upon X of C. Okay. So this is the expression we have calculated yet. Okay. So 1 minute. Give me 1 minute. Next is that. Yes. So we have calculated the expression that I am rewriting the expression Y equivalent is equal to, we have get the value like 0.001512 minus J of 0.003133207 plus 1, sorry, J upon X of C. Okay, this is the expression I get in while when I calculated the Y equivalent. Okay, so to improve the power factor, so power factor to unity meaning equal to 1, that means circuit should be circuit should be pure resistive. Okay, this is the meaning of the unity power factor. Okay, so imaginary term of the admittance meaning this is the your imaginary term. Okay, this is our imaginary term. So if I talk about the unity power factor, that meaning the imaginary term is equal to 0. Okay, so imaginary term of the admittance should be equal to 0. Okay, so making the J term equal to 0. Now what we need to do is making the J term equal to 0. So value is that like that minus 0.003133207 plus 1 upon XC is equal to 0. So here I am taking the J common and by the cross multiplication I will get the value equal to 0.7. Okay. So from here I take the J common. Okay. From this expression I can rewrite that 1 upon XC is equal to 0.003132007. Okay, or Xc is equal to now 319.27 ohms. Okay. Also, we know that the X of C is equal to 1 upon omega C, meaning 1 upon 2 pi f C. Okay. So, here, from here, E is equal to 1 upon 2 pi f into Xc. So, let's calculate the value of the capacitance. Value of the capacitance will be 1 upon 2 pi 250. X value of the X is that 319.27. Okay, so which is equal to 9.96 microfarad. Okay, so this is the required value of the capacitance which helps the circuit or which helps the circuit to improve the power factor by unity. Okay, this is how we have calculated the value of the capacitor, and in the previous case we have calculated the inductance. Okay, so thank you very much. Please like and subscribe our channel.